let's go ahead and do a couple more examples from section 6.4. So this is problem 8 in the homework. And it says the number of hours of reserve capacity of 10 randomly selected automotive batteries is shown to the right. Assume the sample is taken from a normally distributed population. We want to construct a 95% confidence intervals for the population variance sigma squared, and then the population standard deviation sigma. Okay, so let's go ahead and copy the data into StatCrunch. And then paste it in an empty column. And you can rename the column if you'd wish, but you don't have to. Okay, so let's go to the stat menu. Go to variance stats with one sample. And since we have the data, select with data. Okay, and then select the column that contains the data. And we're going to do a 95% confidence interval, so we're going to leave that as it is. And we can include the confidence interval plot. Okay, so we can see the name of the variable, so I've named it battery capacity in hours. This is the sample variance S squared, so it's 0.0509. Okay, and the degrees of freedom is the sample size minus 1, so there are 10 data points, so our degrees of freedom is 9. Okay, and these are the lower and upper limits of the confidence interval for the variance. Okay, so we're going to go ahead and round these to 3 decimal places, so 0.024 is that lower limit. Okay, and then the upper limit rounded to 3 decimal places is 0.1069. So that 9 is going to get rounded up to a 10. So replace the 9 with a 0, carry the 1 on the 6 there. So rounded to 3 decimal places, it becomes 0.170. Okay, 0.170. Okay, then we'll ask for an interpretation. Okay, and the only answer choice that makes sense with how we've written our interpretations for confidence intervals is answer choice B. And it says with 95% confidence, it can be said that the population variance of the reserve capacity of all automotive batteries, right, is between 0.024 and 0.170. Okay, that was a mistake. I meant to type 0.170. Oops. Okay, good. All right, so now let's get the confidence interval for the standard deviation. Okay, so all we do is we take the square root of the lower and upper limits respectively. So the square roots of 0.024 is 0.1549, so when rounded to 3 decimal places is 0.15. Okay, so 0.155. Okay, and then the square root of the upper limits of 0.170. Okay, it's 0.412. Okay, and then select the most reasonable interpretation. Okay, this looks like answer choice B. So with 95% confidence, we could say that the standard deviation of the reserve capacity of all automotive batteries, okay, is between 0.155 and 0.412 hours. Okay, and we'll do one more question. Okay, and it says that the waiting times in minutes of a random sample of 20 people at a bank have a sample standard deviation of 3.8 minutes. Construct a confidence interval for the population variance sigma squared and the population standard deviation sigma, and we're going to use a 90% level of confidence. All right, and we're assuming that the sample is from a normally distributed population. Okay, so this next problem says that the waiting times in minutes of a random sample of 20 people at a bank have a sample standard deviation of 3.8 minutes. All right, we want to construct a confidence interval for the population variance, sigma squared, and the population standard deviation, sigma. Okay, we're going to use a 90% level of confidence, and we're going to assume the sample is from a normally distributed population. Okay, so notice that there is no data given in the problem. Okay, but we could still use the same function to get the confidence interval. So we're going to go to the stat menu, variance stats, okay, with one sample. So because we don't have the data, we have the summary of the data, we're going to select with summary. Okay, so in the problem, it tells us that the sample standard deviation is 3.8. Okay, but in StatCrunch, okay, it asks when it asks us for the summary statistics, right? It asks for the sample variance and the sample size. Okay, so the sample size is 20, right? It says that in the problem. So there are 20 people in our sample, so 20 goes here. Okay, but what about the sample variance, right? How do we calculate the sample variance if we have the sample standard deviation? Okay, so it turns out that if you want the variance but you have the standard deviation, right? You raise the standard deviation to the second power. Okay, so we can just real quickly put that on our calculators. So 0.38 to the second power. All right, or you can literally do 3.8 times 3.8 or whatever the standard deviation is that's given to you. Right, so our sample variance then will be 14.44. Okay, that goes here. Okay, that's really important because if you put the sample standard deviation here, you're going to get the wrong answer. All right, and we're going to select the confidence option for a confidence interval, and then type in the confidence level, which is 90%. And we can include a plotted red confidence interval, but that's not required. Let's click compute. Okay, so we got the sample variance from the problem, which is 14.44. The degrees of freedom, which is the sample size minus 1, and the lower limit and the upper limit of our confidence interval. Okay, so we're going to go and round these to one decimal place. Okay, so the lower limit rounded to one decimal place is 9.1. Okay, and then the upper limit rounded to one decimal place is 27.1. Let's check our answer. Okay. All right, then we select the correct interpretation, putting in the lower and upper limits. So so it looks like answer choice B. So 9.1 goes here, 27.1 is here. Okay, so you get the corresponding confidence interval for the standard deviation. Okay, we're going to take the square root of 9.1. Let me try that again. So square root of 9.1, and then the square root of 27.1. Okay, so rounded to one decimal place, the confidence interval limits for the standard deviation is 3.0 and 5.2. Okay, and we select the correct interpretation. All right, looks like answer choice C. Okay, you can read that on your own. Right, so the lower limit goes here in this box, followed by the upper limit in the other box. All right, we've correctly completed question 9 from the homework. Thank you for watching.